Let's apply stoichiometry to acid-base neutralization reactions. What volume of a 0.035 molar sodium hydroxide solution is needed to react completely with 45 milliliters of a 0.095 molar solution of perchloric acid? In this type of a problem, what we're trying to do is figure out the volume of one of the reactants needed to react completely with the other reactant. So the first thing we need to do is write a balanced chemical equation. So it's sodium hydroxide. I'm going to leave off the state symbols for clarity. Sodium hydroxide, which is in solution, reacts with perchloric acid, common strong acid, HClO4, to give us salt plus water. The salt will be the sodium perchlorate salt. So that's going to be sodium ClO4. Sodium has a +1 charge, perchlorate has a -1 charge, so it's a 1-to-1 ratio cation to anion plus water. So as written, this reaction is balanced. Now we need to answer the question. Let's write here what's given about each of these reactants. Well, we want to know the volume of the sodium hydroxide, and the concentration is 0.035 molar. We are given 45 milliliters of the other reactant, perchloric acid, and it has a concentration of 0.095 molar. Okay, so to work this problem, then since we're given a volume and a concentration in units of moles per liter, we know from that information we can determine the number of moles of this reactant. And once we have the number of moles of one reactant, we can very easily, using our stoichiometry, determine the number of moles of the other reactant, and then using the molar concentration, determine the unknown volume needed. Okay, so that's going to be our our conversion sequence. So let's start with what's given. Now, one thing to note is this molar unit. Remember, it's moles per liter. So if we're going to convert from volume to moles using the mole per liter unit, or the molar unit, then we have to make sure our volume is expressed in liters. So we're going to start with this volume expressed in liters. So 45 milliliters is the same as 0.045 liters of perchloric acid. And to convert now to moles of that acid, we just need to use this molar concentration, and it's in units of moles per liter, so I'll write 0.095 moles of the perchloric acid per liter of perchloric acid. Okay, so that unit's going to cancel. I'm now in units of moles of perchloric acid, so to get from moles of one reactant to the other, I just use the stoichiometry. These are in a 1-to-1 molar ratio. So 1 mole of perchloric acid will react with 1 mole of sodium hydroxide. So now I'm in units of moles of sodium hydroxide. To get back to volume, which is what's wanted, I'm going to use the given concentration, but I'm going to put the molar unit on the bottom so I can get the volume unit on the top. So it's going to be 0.035 moles of sodium hydroxide per 1 mole of sodium hydroxide. Now I'll be in the desired, excuse me, per 1 liter, I should say, of sodium hydroxide, my bad. So now the units cancel. If I plug all of those numbers into my calculator, 0.045 times 0.095 divided by 0.035, I get the number 0.1221, etc., and the volume is liters. But I want to express that in milliliters since that's how we started, and we have two significant figures. So the correct answer here to two significant figures is 120 milliliters of the sodium hydroxide solution needed to neutralize that amount of perchloric acid.